A summary of the TLC drug analysis experiment that was run. So in this experiment, the thin layer chromatography was used to analyze the different drug samples that were given. In this case, we were given pills, and so we were given Benadryl, aspirin, Tylenol, ibuprofen, caffeine, and Excedrin. And so these were all given in pill form. The Benadryl the capsule was able to be opened up and just poured in as a powder. The other pills were crushed up to a fine powder and all of them were each placed into 2 milliliters of methanol and shaken up a little bit and then left to sit for 30 minutes to dissolve as much as possible, and it allowed for the methanol to soak up as much of that drug as possible. Once this was done, the 2 TLC plates were used, and they were marked a centimeter from the bottom, and so a drop of each drug was placed on that 1 centimeter line, and so the drop of the drug would be placed and allowed to air dry, and then another drop would be placed, and this was done 3 times for each of the drugs, and there were 3 drugs on each TLC plate. And this was done 3 times to ensure that the concentration of these drugs on the TLC plates were high. And so after this was completed and they were fully dried, 5 milliliters of methanol were placed into a 250 milliliter beaker, and the TLC plate was placed standing upright in there with just the very bottom of the plate below the 1 centimeter line placed in the methanol to allow it to soak and move up the plate. And it was very important to note that where the drug samples were placed did not touch the liquid that it was being put in, so this avoided any contamination or spread of the drugs to one another. And so these were left to sit in that methanol solution, the developing agent, until the methanol moved up to about a centimeter from the top, and then these were removed and that line was marked and they were allowed to air dry. And once these air dried, then they were analyzed with a UV light to show the drops and show where the samples had moved up on the silica gel plate. And so we were able to see a dot where the drug had moved up and been pulled up by the methanol, and these spots were marked and measured and used to calculate the RF values. And so a little bit the summary of the data. So the Benadryl solution moved up 2.3 centimeters, the aspirin moved up 3.0 centimeters, the caffeine moved up 4.9 centimeters, the ibuprofen moved up 5.1 centimeters, the Tylenol moved up 2.6 centimeters, and the Excedrin had 2 drops. And so the first one moved up 3.0 centimeters, and the second one moved up 4.7 centimeters. And so what this showed is that each of these drugs moved up the TLC plate at a different distance, which resulted in all of them having a different RF value because these are used in the calculation. And so the separation that was observed successfully distinguished between the drugs and show that there were different chemical properties between the drugs, mostly due to their polarity and the interactions that they would have with the mobile and stationary phases. And this also showed that mixtures can be analyzed because Excedrin showed up as a mixture. It showed that it had 2 different chemicals or compounds within it. And also the RF values or the spots, the distance of the spots showed some similarities to caffeine and aspirin, with aspirin also being at 3.0 centimeters and caffeine being at 4.9 centimeters, and Excedrin had a drop at 3.0 and 4.7 centimeters. So this raises the question to if Excedrin is a mixture of aspirin and caffeine. I talked a little bit about the mobile phase and the stationary phase. So the mobile phase in this solution or this experiment was the methanol or the solvent that was used to pull the drug samples up the plate. and the stationary phase was the silica gel coating that was on the plate itself. And so this coating is where the drugs were placed, and it allowed for an interaction to happen with the drugs and the chemical properties. And then the mobile phase was used to pull those drug samples up. And so the significance of the stationary phase and the mobile phase is that the stationary phase will hold on to the different compounds and the different chemicals at a different rate from each other. And the mobile phase will also interact and pull up the samples differently too. And so the mobile phase is determined based on solubility. So the more soluble the drug is, the higher up it's going to go. The less soluble, the less it's going to move, because it's not going to get pulled up with that methanol. And with the stationary phase, it interacts and wants to hold on to those compounds. And so the more that it holds on, the more that it interacts, the lower down the drug sample will stay, and the less it interacts, the higher up that it will be pulled. And so this is very significant because the way that they're interacting with each other and with the drug samples will determine how far up these drugs will be pulled. And so some of these drugs move at a different rate from one another in the stationary phase because of their chemical properties, especially polarity. Polarity is the most important one of these. So the silica gel will interact, and as the drugs interact more strongly with that silica gel, they will move up a lot slower, and in turn will move up less. And then those that don't interact as strong and are more soluble within the mobile phase, the methanol, they will travel further up the plate, and this will cause the separation that we saw. So a little bit about the RF value that I talked about earlier. The RF value is calculated by taking the distance that the drug moved up the plate and dividing it by that distance, the 1 centimeter marked on the bottom, and how far the methanol traveled up from there. So that distance that the drug moved up the sample is divided by that, and it gives an RF value. In this case, the Benadryl had an RF value of 0.418. The aspirin had an RF value of 0.545. Caffeine had an RF value of 0.891. Ibuprofen had an RF value of 0.879. Tylenol had an RF value of 0.448. And Excedrin had 2 RF values, one being 0.517 and one being 0.810. And as I talked about earlier, aspirin had an RF value of 0.545, and this is similar to the 0.517 on the Excedrin. And then caffeine had an RF value of 0.891, and this was somewhat similar to the 0.810 on the Excedrin. And so this is important because each compound is going to have a different RF value, and it will also show, like the Excedrin, it'll show that there's possibly a link between those two, caffeine and aspirin, based on those similar RF values and the similar distances that were traveled up. And so it allows us to not necessarily identify a compound, identify an unknown based on that RF value, because mobile phase and stationary phase and everything can have different impacts on it. But it does show that there could be some similarities, and it could potentially be that compound. And so this is why the TLC is considered a presumptive test, because it will provide that initial evidence about the identity of the substances and show the separation based on the RF values. However, it's not really a definitive experiment that will give an exact identity and give a for sure answer on what the compound is. It can be used in this setting to show the similarities between the Excedrin and the aspirin and the caffeine, because they were all conducted at the same time using the same solvent and the same stationary phase. And so it allows for the implication that there could be aspirin and caffeine in that Excedrin compound due to where they moved up on the plates. However, there is no way to fully say with confidence that that is what is in that compound, and it is also a presumptive test, because you cannot take an unknown and just calculate the RF value and say, yes, it is this compound. And so that is why further analysis is needed, because it may give you answers and give you a compound to look for, like, yes, maybe it will be this compound, or maybe it is this compound. And so then further testing can be done to show, or maybe you have an RF value of a drug that you're looking for and it's completely different, and so you know that that drug most likely is not in that sample because it didn't move up the TLC plate like you would have expected it to if it was that drug sample. So then no further testing will be needed, because then that drug sample is not in there. And so that is why TLC is just a presumptive test and not a confirmatory test.